Welcome to today's tutorial. Today we'll be looking at mensuration. Alright, now get your written materials ready with your calculators. We'll be right back.
To enjoy mathematics, you need to know the basics. We at Mathematics Simplified is here to make it easy. Ensure your notification button is on, like, subscribe, and share with friends.
Welcome back. Now we'll be looking at volume of pyramids and cone. Now this is a square base, assuming this is a square base pyramid. Now the volume of a square base pyramid is calculated by 1 over 3 bh squared, b squared h. Now the volume of cone is calculated as 1 over 3 by r squared h. So in general, to calculate the volume of a pyramid or a cone, we use 1 over 3 area base area times our height. Remember, in our last discussion, we said to calculate the volume of a solid shape, we use area base times height. Now, because we are dealing with pyramids and cone, we are having our 1 over 3 inclusive to 8 base area times height. Example 1 says a 216 degree sector of a circle of radius 5 cm is bent to form a cone. Find the radius of the base of the cone and its vertical angle. Now, for us to solve this, alright, we are first of all going to represent this sector. Now, when we talk about a sector is a part of a circle formed by 2 radii and an arc. Okay, now if we have this, we know that this angle forms a 216 degrees. Okay, now if we fold this to form a cone, they said it was folded to form a cone. Okay, now we should find the vertical angle. This place is referred to as the vertical angle, and this place is referred to as the radius. Okay, now here is 5 cm. Now this 5 cm forms the slant height of our cone. Okay, 5 cm forms the slant height of our cone. But one thing we have to recognize here and remember here is that the circumference of the cone, the circumference of this cone is equal to the length of arc. Remember that circumference of cone equals to length of arc. Now, this length of arc is what forms the circumference of our cone. Alright? Now, for us to know the circumference of the cone, we need to calculate the length of arc. And in calculating the length of arc, we know that for circumference of cone, we are having 2 pi r as our formula for circumference, and for calculating length of arc, we are having theta over 360 times 2 pi r. Okay? Now, where this r is our radius for the arc, and this r is the radius for our circle, which is the r we are looking for. So let me call this r1 and r2. So, okay, big R and small r, that would be better. Big R and small r, so this would be big R. Okay, now we know our theta is already 216, our big R is 5, and our pi is 22 over 7. Now, in putting this into here, into this work, we are going to have 2 times 22/7 times R equals to 216/360 times 2 times 22/7 times 5/1. Okay, now we can break this down. We can break this down to become 44 R all over 7 equals to 216/360 times 44/7 times 5/1. Okay, let's move this 2 over to this. Now if we are moving this over to this becomes R equals to 216 all over 360 times 5/1. Now if we have times 44/7, when this comes over, it becomes inverse times 7/44. So this will cancel out this. Okay, that's why we're having R equals to 3 and 216 times 5. So R equals to, our value of R will become 216 times 5, which is giving us 1008 divided by 360. 360. So our R will give us 3 cm. So our radius will be 3 cm. Now, if our radius is 3 cm, now I'm bringing out this. So our radius here is 3 cm and our slant height is 5. They say we should calculate this angle. Let's call this angle theta. Now, knowing that this is 90 degrees, this forms a right angled triangle. Okay, now, and we know that using Pythagoras theorem, we know that hypotenuse squared is equal to opposite squared and adjacent squared. But now we are going to use what we call SOHCAHTOA. SOHCAHTOA. Now this simply means sine theta equals to opposite over hypotenuse, cos theta equals to adjacent over hypotenuse, and tan theta equals to opposite over adjacent. Okay, now here this is our hypotenuse for this triangle, this is our adjacent, and this is our opposite. So now we have our opposite, we have our hypotenuse, so we are going to use sine. So sine theta, which we are looking for, equals to opposite over hypotenuse, opposite over hypotenuse, which will give us 3/5. So sine theta equals to 3 divided by 5. 3 divided by 5 will give us 0.6. So theta equals to sine inverse of 0.6, which will give us sine inverse of 0.6 will give us 36.87. Now, this angle is 36.87, but since it's a full cone, remember, it's a full cone, so the other angle here will also be 36.87. So our vertical angle, now our vertical angle will be equals to 36.87 times 2, which will give us 73.74 degrees. Okay, now if it's to the nearest degree, this will give us 74 degrees. Our second question says, a water tank is 1.2 meters square and 1.35 meter deep. It is half full of water. How many times can a 9-liter bucket be filled from the tank? Don't forget to like, subscribe, and click on the notification button for more updates. Alright, Looking at our question, now the first line says a water tank is 1.2 meters square. That means we are looking at a square based tank. Okay, the base is a square. Okay, so this will be 1.2, 1.2. Then the height will be 1.35 meter. Okay, now if we are to calculate the volume of this tank, volume of tank equals to 1.2 times 1.2 times 1.2 times 1.35. Now our volume of tank will be equals to 1.944 meters cube. All right. Now the next line says it is half full of water. That means halfway full, halfway empty. Okay, it is half full of water. That means volume of water will become 1.944 divided by 2. Why? Because it is halfway. So that will give us 0.972 meters cube. Okay, now we've known the volume of water in it. The next question, our question now says, how many times can a 9-liter bucket be filled from the tank? The question you should ask yourself is, how many meter cube forms a liter? We know that 1 meter cube equals to 1,000 liters. Okay, 1 meter cube equals to 1,000 liters, and we are having 0.972 meters cube. So for the number of liters will become 0.972 times 1,000. So this will give us 1, 2, 3. This will give us 972 liters. So if we have 972 liters of water in the tank, then how many times can we get 9 buckets out of this? This will become 972 divided by 9, which will give us 9 here, 1, into 7, 0, into 72, 8. So we can get a 9 liters bucket of water to be filled from that tank 108 times. Don't forget to subscribe to our station, to our channel, to get more updates on this. Now, third question says, a measuring cylinder of radius 3 cm. We have our cylinder solution of 3 cm. The radius is 3 cm. Okay, now contains a water into a height of 49 cm. Let's say the height is 49 cm. Okay, now if this water is poured into a smaller cylinder of radius 7 cm, okay, it says calculate the height of the water in this. Now, for us to calculate our volume of water in our cylinder, we have it as pi r squared h. Okay, so for us to calculate the volume of water here, the volume of water here is going to become 22 over 7 times 3 times 3 times our height, 49. Okay, now the volume of water here is going to give us 7 here, 1, 7, 2, 49, 7. So this becomes 22 times 9 times 7. which is 22 times 63. So 9 times 7 will give us 63 times 22. So the volume of water here will become 1,386 cm cube. Okay, that's the volume of water in here. So for us to calculate the volume, the height of it here, we are going to use it as volume equals to pi r squared h. Alright? Now, where our h will be the height of the water we are looking for. So our volume of water, this will give us 1386 equals to 22 over 7 times radius 7 times 7 times h. So this cancels this, leaving us with 1386 equals to 22 times 7 will give us 154h. So h equals to 1386 divided by 154. Okay, which is our h will give us 9 cm. So the volume of water here will be 9 cm. In looking at addition and subtraction of volumes, it is important to understand that there are composite solids and there are hollowed shapes. Now, in composite solids, example, we have the composite solids that we have a cone and a cylinder. These are composite solids. And we also have a square-based pyramid and a cube is also a composite solid. Then for hollow shape, what are hollow shape? Okay, composite solids are solids, two solids that form as one. Okay, they are made up of two solid shape. Okay, now while hollowed shapes are those shapes or figures, those shapes that have holes. Okay, hollow means hole. They are open in between. Okay, like our hollowed blocks, like our pipes, like our boxes, all those are hollowed shapes. Okay, now in addition and subtraction of volumes, we'll be considering composite shapes and our hollowed shapes. So we'll dive right into it, looking at examples for each of them, for composite and for the hollowed shapes. Don't forget to subscribe and like our channel for more updates. Our question 1 says, the height of a cone is 20 cm. The height and base diameter of a cylinder are 40 cm and 30 cm respectively. Now, it says, calculate the volume of solid. Now, if we have a cone and a cylinder, okay, now, this is what this statement means. A cone of 20 cm height, the height is 20 cm, 20 cm, okay, let me put it in. 20 cm. Alright, that's the height of the cone. Now, they say the base diameter of the cylinder, our diameter of cylinder is 40 cm. Then the height, okay, the height is 40 cm, sorry. The height is 40 cm and the base diameter is 30. So this is 30 and this is 40. Alright, it says calculate the volume of this solid. Now, in order to calculate the volume of this solid, we'll calculate volume of cone and volume of our cylinder. Okay, now how do we calculate volume of cone? If we remember, we said that for volume of cone, we are having it as volume of cone, we are having it as 1/3 by r squared h. Okay, that's for our volume of cone. Now, for volume of cylinder, we are having it as by r squared h. That's for our volume of cylinder. Okay, now let's calculate the volume of cone, knowing that our cone, we have our height to be 20 and our radius, since this is 30 in diameter, our radius will become 15. Alright, now for the cylinder, we have our radius to be 15 and our height to be 40. So imputing these figures in here, so volume of cone will become, volume of cone will give us 1/3 times pi, which is 22/7, times radius, which is 15, times 15, times our height, which is 20. While volume of cylinder will become 22/7 pi times 15 times 15 times our height, which is 40. All over 1, all over 1. Now, if we calculate this, 3 here, 1, 3 here, 5. Okay, we are having 22/7 times 5 times 15 times 20, all over 1. Okay, plus 22 times 15 times 15 times 40, all over 7. Alright, what are we going to have? There we are having 22 times 5 times 15 times 20. This is 714.285. Okay, 0.286, let me put that as 0.286 plus 22 times 15 times 15 times 40 divided by 7 would give me 28,285.714. Now, if we add these two together, we have 28,285.714 plus 4,714.285. We are having it as 32,999.999. Now, approximately 33,000 cm cube. That's the three significant figures. Okay, so that will be our volume for the composite solid. Our next question says, find the mass of a cylindrical iron pipe 2.1 meter long and 12 cm in external diameter. If the metal is 1 cm thick and of density 7.8 grams per cm cube. Now let's represent this in the diagram. Let's assume that this is our pipe. Okay? Now, they say the pipe is 2.1 meter long, alright? And the external diameter is 12 cm. Now, that means it has an internal diameter. We all know that a pipe is a hollowed object, okay? They said here to here is 1 cm. Here to here is 1 cm. Now, if we subtract 1 plus 1 is 2. If we subtract 2, our internal diameter will become 10 cm. So our internal diameter is 10 cm and our external diameter is 12 cm and it is 1.2 meter long. But now we have to, for us to calculate the volume of this, okay, we have to turn this meter to centimeter, and we know that 100 cm equals to 1 meter. So therefore 2.1 meter equals to 2.1 times 100, which will give us 210 centimeter. Okay, now knowing that our length is 210 centimeter, let's go ahead and calculate the volume of the cylinder. Now we know that volume of cylinder equals to pi r squared h. Okay, that's the volume of cylinder. Now for the external, we are going to look at external and internal. Now for the external, we are having our volume to become pi r is 22 over 7 times our r, which is half of 12, 6 times 6 times our height, which is 210. Okay, if we solve this out, we would have 22 divided by 7 times 36 times 210. We are having 23,760 cm cube. That's for the external. Now for the internal volume, we are having 22 over 7 times our radius will be half of 10, 5 times 5 times height is still the same, it's not changing. So we'll be having 22 divided by 7 times 25 times 210. So we are having 16,500 cm cube. Now for us to calculate the mass of material used. Okay, volume of material used. Let's look at the volume first. Volume of material used will become external volume minus internal volume, which is 23,760 minus 16,500, which will give us 23,760 minus 16,500 will give us 7,260 cm cube. Okay, 7,260 cm cube is what we have. But now they told us that the density is 7.8 per cm cube. So we have density equals to 7.8 grams per cm cube. Okay, now so that means for 1 cm cube we are having 7.8 grams. Mass of material, we are going to have 7,260 times 7.8 grams per cm cube, which will give us 56,628 grams. Okay, now since it's in grams, we are converting it to kg. Converting to kg, we know that 1,000 grams equals to 1 kg. So this will become 56,628 divided by 8,000, which will give us 56.628 kilogram. Now to the nearest three significant figure will become 56.6 kg. So the mass of material used in making the pipe is 56.6 kg. We've come to the end of today's class. Don't forget to subscribe, like, and click on your notification button to get updated with our latest topical teachings. If you have any questions or comments, put them in the comment section below.